here to solve problems at that level, to solve problems large and small. And I think that's where the opportunities are. And so I do try to encourage folks that are in this industry to say, make sure you understand data really well and don't be afraid to code, because there's going to come a time when you are going to have a task that's going to make sense to automate. And if you can do that, then you have a lot of value to our industry, and you have a lot of value to the world.
Welcome to another episode of the Mapscaping Podcast. My name is Daniel, and this is a podcast for the geospatial community. Today on the show, I'm going to be talking to Mike Dodbell, and I originally met Mike through his work on a blog called GeoHipster. And I thought it'd be really interesting to get Mike on the show and hear a little bit about his story, how he got involved in geospatial, and perhaps get him to look into his crystal ball and tell us where geospatial as an industry is heading, and see if he can identify any big trends for us. Before we jump into the interview with Mike, I'd like to thank our generous sponsor, Hive Mapper. That's Hive as in Beehive Mapper. This is the platform that lets you upload raw video footage to the cloud and have it automatically converted into 3D geospatial data. They do a lot of other great things, and if you're flying drones and collecting video data, it's well worth checking them out. Okay, on with the interview. Mike, welcome to the show. Thank you so much for taking the time. We've tried this a couple of times before, but I'm really hopeful that it's gonna work this time. We've been sort of hampered by poor sound quality, but the reason I invited you along was because you're a person who's been in the industry and the geospatial community for quite a while now, through work, so that professional side, and you're also the CEO of a blog called GeoHipster. And through your work with GeoHipster, you've had the opportunity to interview a lot of people in this space. So I'm thinking you can bring a lot of things to the table in terms of insights into the industry, past, future, present, that kind of thing. And once again, welcome to the show. I'm looking forward to the conversation.
Thanks, and thanks for having me. And I hope I can live up to all of those expectations you just laid out in front of me.
From a pre-interview, I'm sure you can, because I've really enjoyed those conversations as well. Hey, before we jump into things, perhaps you could just give the audience a brief overview of your history and how you got into the geospatial world.
Right. Well, I got into GIS by accident, essentially, much like I became CEO of GeoHipster by accident. I was a forestry major in college. I really liked being outside and being in nature. It took me 4 years of college to realize that I was too much of a klutz to be walking around in the woods with a chainsaw. But lucky for me, I had a great teacher for an aerial photography class, and for the very first time, I saw an aerial photography at that scale of campus, basically, and was just blown away and really enjoyed the class. And the teacher encouraged me to take his GIS class the next semester, and I did, and I really, really enjoyed it. And so much so that I helped him TA the class the following spring, my senior year. And then, to be honest, I looked for jobs in forestry and wildlife with my wildlife minor when I got out of college, but I couldn't find any where I was living. And I found a job after about 6 months of being out of work. I found a job for a small regional planning commission doing GIS. And from there, my career has basically led itself one to another. I've been able to support a lot of different government agencies, from transportation and transit to agriculture to health and human services, commerce, you name it. A lot of different areas I've been able to support and enjoy and learn about, and really fell into the technology, fell into the field. But I found that my natural resources background has helped me in a lot of different ways in that field in being successful and basically helping people solve problems. That's what my job has been about. I really love maps. It took me a long time to discover that, but I do love maps. I love the spatial technologies. I really don't like waste. I don't like when people waste their time, taking the wrong road to get where they're trying to go or something like that. So I like people to have information to help them solve problems. And that's been my career, and it's been really enjoyable so far. As you said, it has been over 20 years for me. I hope it's another 20.
Me too. You talked a little bit about forestry there, and I think that was a really natural way of getting into geospatial, at least at that stage. When I think about geospatial, I think about having its roots in environmental science, in things outside. I don't necessarily think about geospatial GIS starting with people saying, how can we make sure this building is connected to another building, and all the things we see happening with digital twins at the moment. That wasn't the birthplace for me. It started with the environmental sciences, and forestry has always been a huge user of GIS. That's for sure. So I can completely understand that sort of pathway that you took. But you said a few different things there, and a lot of it seems to be revolving around solving problems and support. So you don't necessarily see GIS geospatial as the lead singer in the band. It sounds like you view it as something that happens in the background, that's a practical thing, and that is used in combination with other things or other sciences, other disciplines.
Yeah, that's been in my experience. I certainly think that geospatial can be the lead singer in the band, as you put it. Really, when the power of GIS, as many of us in the industry know, is in the analysis, in ways of viewing places that you can't just see with a spreadsheet or a chart. And that analysis of combining layers to bring you to new conclusions and to see things in a different way is really powerful. However, um, that's not been my career. I probably last did an analysis when I was in my 20s. I really leave that up to my customers lots of times. My job has been getting them the information that they need, making sure they have access to the technology, sometimes automating tasks to get that information, to bring it to them, that sort of thing, and then letting them run with that analysis level and take it to where they need to go for what their problems are. And sometimes I help them figure out what that analysis is. They explain to me their problems, and I listen and try to right size the solution for them. Sometimes that is an analysis, but oftentimes I leave that up to them. And so when I am in that support role, I am the bass player in the band, and I am a bass player as another side gig myself. But that's a role that fits me well. It's something that I like to do. I like to support other people. I am a bit of an extrovert most of the time, but I'm also have an introverted side, and bass playing fits that really well. So it's you're there, you're important, you're a supportive role, but you're not the star, and that's okay.
So you mentioned there that there was an analysis role in the stuff that happened in the background to get to the data, to get the data to the stage where it could be analyzed, and you chose the stuff in the background, that work that happens, the cleaning of the data, and perhaps building the software that displays it or puts it into another system. What would you, and there's, of course, there's lots of other different roles within GIS geospatial out there. What would you say to someone coming out of college now? Where should they focus their time? Should they try and be a person in the background, that more sort of IT heavy person, perhaps, that's interested in scripting and servers and databases? Should they focus on analysis? Should there be more attention on something like visualization? Should they go into communication, just understanding how to communicate these ideas and tell stories to people, that selling in of a project? Do you have any sort of recommendations around that?
Yeah. Typically, what I tell students, lots of times I do informational interviews with students or folks that are just getting into the field. And what I tell them right off the bat, I'm brutally frank, at least in America, if you like the scripting, if you like coding, if you like databases, that there's better pay in the IT side of GIS for sure. However, if you really like the analysis aspect, if you like sort of making visualizations and whatnot, then you want to try to get to know well a certain vertical, whether that's natural resources or education or transportation, logistics, that sort of thing. If you get to know that vertical really well, then you could take your skills in GIS and use it to solve problems in that vertical. And you'll probably be the one doing the analysis. You'll probably be the one actually plugging in the numbers, actually creating the visualizations, helping the decision makers make decisions and make better decisions through geography. And so, lots of times, at least especially in government, the what we would call the business user, if we wanted a generic term for someone in a vertical, they are making less money than the IT folks. The IT field is more competitive, and so lots of times gets paid better. So that's what I tell folks. But I also tell them, if you're not sure, but you have an opportunity in a certain vertical, do your best with that vertical, and you'd be surprised, given your picture of the world and your use of an integrative technology, how often you may be able to take that knowledge and apply it somewhere else. For example, I tell people frequently that my natural resources background helped me with communications. You know, you look at a 40 or 60 acre area of natural forest, and that is vastly more complex in terms of a system than anything that we can come up with as humans. And so being able to understand a little bit about how it works and how to manage it, and then being able to communicate that to people requires very high level communication skills, both verbal and written. And I've been able to use those skills in my career to explain complex things like databases or scale dependencies or a spatial join, and be able to use that. So I tell people that don't, if you could still leverage what you learn in a vertical in other verticals if you change your mind and decide you want to go into the support role. But you really have to be willing to dive into code and not be afraid of writing a script or writing a SQL query, that kind of thing.
Yeah, I really like the way you broke that up there into that IT side, the more sort of technical role, and the visualization side, the analysis side. And I think that's a really important thing to sort of reiterate here, is that it is really important to have subject knowledge in one of those verticals. If you go into the analysis side, you can't just show up and say and treat everything as points, lines, and polygons and rasters at that stage. You need to understand the data that you're looking at. But the IT side, you can, everything is just zeros and ones at that stage. I'm oversimplifying, of course, but I hope that you understand what I'm trying to get at here. Do you think that would be a fair assessment?
Yeah, I think in IT we are better IT people if we do take some time to understand the vertical. We probably don't understand it to the same level as our customers, and we shouldn't try to. That's a waste of our time. It's a waste of their time. But to understand it to the level where we can start translating things like, okay, I need a map that can tell me what school district I live in. We can translate that to, okay, I'm going to need to have an input for an address. I'm going to have to use a geocoder, and then I'm going to have to do a point polygon lookup. So you have to understand the need at a basic level. And that makes you a better IT person to do that. However, that point polygon lookup, something that all of us geospatial people understand, it's the same thing everywhere. Every time you need that lookup, it functions the same way everywhere. It's the same concept. There's different mapping libraries to do it. There's different code. There's different applications you can do it. There's 100 different ways to actually get it done, but the concept is the same. And so, yes, you can take it and apply it to many different places.
Because you've decided to focus most of your career on the IT side of geospatial, of GIS, perhaps we should stay there for a little while. Can you talk us through some of the changes, some of the really sort of big overarching changes you've seen in this space in the last 10, 15 years?
Yeah, absolutely. I think this is an obvious answer, but I think the biggest change in the industry over the last 10 to 20 years has been the explosion of open source software and companies built on open source software that have challenged Esri to step up their game. And to be honest, they really have stepped up their game. But to make it be a space where there's a lot more choice in the tools that are used by people. So I think that's the biggest change I've seen in the last 10 or 20 years. And, to be honest, Esri's still a dominant player, of course, and they do make really good products that do good work and provide good solutions for folks. And so there's a lot of folks that don't even realize that there's a product called QGIS or, a mapping library called Leaflet. There's a lot of folks that don't realize that, but there are more folks now and more options now than there were 10 or 20 years ago for folks that are willing to go that next step, take that next dive, look into alternatives and say, you know what? This problem is a screwdriver. I need a new tool. I can't just use the same hammer. So I think that's been the biggest thing. One of the other things that has been really, really cool to see is the explosion of open data options that are out there. Um, our state, the state I work in Minnesota, has been publishing GIS data for more than 20 years. So we've been doing that free and downloadable for a really long time. But in the last 10 or 20 years, we're seeing the various national governments, all kinds of other states, cities, almost everybody has an open data portal. It's almost overdone. We're drowning in data, and that's a new problem. But to my perspective, that's better than not being able to get any data. The fact that you can download Landsat, scenes free of charge whenever you want. You can get data from Copernicus or from the USDA's Farm Service Agency. The fact that you can just browse whatever you want on Google Maps or Google Earth. That's been really, really tremendous for our industry, just for our visualization and our the way our industry is seen and our exposure to the general world, but also opening up new opportunities for us. So those trends, open source, open data, and just more sort of democratization of the aspects of what we do, geography and maps, has been really, really cool to see.
Yeah, and I, as a GIS user myself, I really appreciate the amount of options there is out there, and I think that's what you're getting at there. If we could pack it down into one word as options, we have options now, and we're getting more and more options each day, and it's almost getting to the point where it's difficult to choose. But I think that analogy that you gave is like, oh, this is a problem for a screwdriver. I better put away my hammer and learn something new. I think that's the new challenge that's kind of facing the industry now: is what is the best tool for the job, and you know, can I learn it quick enough to actually apply it? So you talked a little bit about open source data there uh, and software. Is there a time where, if you're a company starting out and you wanted to build a product, would you always consider open source first, or would you go to some software perhaps like Esri? I guess what I'm getting at, I guess what the question should really be is, when would you not choose open source?
Oh, that's a good question. And, this one I'm not really qualified to answer because I've never started a company to, build software or to provide solutions for folks. I've done some outside consulting, but that's about it. Just writing some code. I really think it depends. It depends on the problem. It depends on the company. It depends on what you're trying to solve, what you're trying to fill. If you were, say, a engineering company and your problem was that you're trying to find places to build houses, and you've got folks that are good at real estate and good at markets, but don't really understand computers very well, then the Esri software suite could really meet a niche for you, or actually more likely a business partner of Esri might meet a niche for you in terms of selling you something that out of the box you spend a few hours learning how to use, but then it gets you what you need, site selection of properties or demographic understandings of markets and things like that. So, whereas if you're, say, a straight up consulting firm, someone that just wants to do consulting for anyone that comes to you, and you're comfortable either being the coder yourself or hiring the coders and hiring the DBAs and so on and so forth, then to me, it's really great that you have that option of building your products and building your solutions on open source libraries that are out there. You can do almost the entire stack. Well, I shouldn't even say almost. You can do the entire stack in geospatial with open source options. And then, in the best case scenario that we see in the industry, you're not only doing that, building your work standing on the giants of shoulders, but you're also contributing back. Maybe you're a user of PostgreSQL or PostGIS, or maybe you're a user of Map Server, and you say you discover a bug and you file that bug on GitHub, or you contribute to the documentation, or your coding chops are good enough that you contribute to the source code. That's the best case scenario, and it's really great in our industry to see that happening with a lot of companies that are doing that. They're building on top of open source, but then they're also contributing back to open source, and that's really tremendous. That's the ideal, right?
Yeah, yeah, absolutely. And I guess what I was getting at with that question was I think there's so many reasons to use open source that it would be really interesting to hear someone like yourself perhaps give some pushback on this. When do we not use open source? But yeah, I understand, having never started a company yourself, then it's perhaps a bit of a difficult question to answer. But even so, I appreciate your answer on that one.
Yeah, and this I can maybe give a better answer for my customers. People that are using my products and I'm building solutions for. When do I not use open source? Again, it comes down to understanding the problem and right sizing the solution. So if somebody comes to me and they want to do some web editing of geospatial data and information because of my skills and my background and also what I know is available out there and what my capabilities are. I do frequently go to the Esri tools because they are really well built to handle that stack. Where if somebody just wants to see some dots on a map, they've got 100 or 200 dots. These are locations of anything, you name it, a pharmacy, schools, or whatever, and they just want to see those on a web map. I jump right into with Leaflet, jQuery, and Bootstrap, and go to town with that. So it depends. It really, I try to right size the solution to the problem, and sometimes it means not using open source. But I always like to make sure that it's in that option suite to make sure we're holding it up, its pros and cons at an equal level with closed source and proprietary solutions, because that is the way I believe our world and our industry should run.
Yeah, I really like that approach. I really like the approach of let's find the best tool for the job as opposed to being married to one particular solution. So, from our conversation so far, I'm sure that the listeners have got a bit of a feel from where it is you started and where it is that you are in your career path now. When you look back over the last couple of years or the last 10, 15 years in geospatial, do you feel like you're still solving the same kinds of fundamental problems for people, or has your role sort of changed throughout the years?
Oh, that's a good question. I do frequently feel like I'm solving the same problems for people over and over again. I just started a new job and I'm supporting an education department. And I recently had to update some data that essentially is the background to informing point and polygon lookups. So, and I've been doing that over and over again for many years. It's a very common problem that it's probably one of the biggest values that we bring to the IT industry. Basically a point polygon or a spatial join to be able to say like, oh yeah, this spatial data. It is special in some ways in that it's powerful in different ways than just a decimal column or a text column, right? So it's got some powers, but at the same time, it is just another column in the database, and it can be used to answer questions. It can be used to answer queries. It can be joined to other data so you can compile reports that are different than your spreadsheet report. It can be a report that's a map. And so I have been spending probably the last 10 or 15 years explaining that to people, providing that to people, and solving those problems to them. And it's been a lot of fun, and it really never gets old. I'll tell you, it doesn't get old seeing people light up when their data ends up on a map, and that's something that they've never seen before. They've never been able to provide to their own customers before, that sort of thing. It doesn't get old. However, I am seeing in the industry and pining lots of times myself for changes that to be able to leverage the changes that we've seen that are really beneficial things that we've been able to see over the last few years. Just the explosion of satellite imagery and the amazing things that companies like Planet can do with that imagery to be able to analyze automatically every day a new picture of the earth, to be able to say things like, hey, the economy is going to pick up because we're seeing more container ships in port. That's really amazing. And I wish I could spend some time doing that, because that is really a new capability to be able to have high res imagery of the planet every day and to be able to do things with that. That's really cool. And I probably in my career will never get to do that. And that's okay. It's fun to just sort of be along for the ride and show people when that happens. But at the same time, sometimes it's like, okay, yeah, I would like to do some of that kind of thing for my customers, and maybe someday the opportunity will arise that I do get to do that because it's really neat. It's a really eye-opening ability and geospatial to be able to say things like what planet is doing, or to be able to compile a map. I can't remember if it was the Times or the Post recently that compiled a nationwide map of fall leaf color, like peak fall color. I thought that was really cool. So it's great to see that, and if I get to do that, great. If not, I'll keep on joining spatial data to tabular data for folks and putting their dots on the map.
Yeah, I think a lot of GIS geospatial professionals feel the same way. You know, the spectrum is so huge. At one end, we've got people that just need some address data converted to points on a map, and at the other end, we've got people using machine learning to create maps for autonomous vehicles based on imagery that's coming out of cell phones. There's a huge amount of opportunity inside that space there. But I'd like to stay with these sort of fundamentals of GIS. So you're talking about the point and polygon lookup, and another sort of fundamental. It's almost like a law within the geospatial world now. Is this idea that 80% of all data has a spatial component? Would you agree with that?
Well, there's been a lot of discussion over the last 4 or 5 years, especially on Twitter, which is where I get out of my bubble, that that stat is essentially made up. That it was really conjecture and almost mythological. It has been for us about that statistic, and nobody can really say that it was based on empirical evidence or empirical data. However, having said that, I do essentially agree that geography is what we do. Geography is where we live, is where we work. It's our world. Yes, we have this wonderful thing, the internet, that enables you and I to have a conversation 3,000 miles away, I'm guessing, or maybe 4,000 miles away. That's really amazing. But at the same time, I'm sitting in a physical space. I'm dealing with physical temperatures and weathers, and I've got to drive to a physical location later today to do my job. And so geography impacts all of our worlds in so many different ways. And so, where was I going with with this about fundamentals? Oh, 80% of data. Yes. The that I tell people that with all information, you can probably tie something to a physical space somewhere. And what I've been telling my customers in government is that the percentage is probably higher because as a citizen of any state, city, nation, or whatever, your two biggest impacts on your relationship with your government, to put it another way, your relationship with government and the folks that write the laws and build the roads and provide the services to your area. Your relationship with that government is determined primarily by two things, and I've already mentioned them: where you live and where you work. And those are two geography questions. And you name it. So, if you have a long commute, you have a relationship with government for the roads that they built. If you don't have a long commute, you have a relationship with government about where you live and the utilities that are provided to you. And so those are where questions. And so I tell my customers in the public sector, chances are 90% of your data can be tied to a map somehow. As to whether or not you need to map that data, that's a whole different question. But you should have some spatial data in your suite, in your solution stack. You should have some spatial data to use. You should have some of your data matched to spatial areas or points, lines, and polys so that you can communicate about that, so that you can understand it better, because you won't understand it the same way looking at a table or a chart or a graph.
Yeah, I kind of feel the same way about that. 80% of all data has a spatial component, and I think I like it as a tagline, in the same way I like spatial is special. But I think we need to think very carefully about who's listening when we say things like that. And for me, it's
Right.
maybe more of a question of how much data in the world is spatialized. So how much is machine readable spatial, has an
Oh,
x
yeah.
and a y attached to it. And I feel like when we talk about this how much data it has a spatial component. I feel like we get back to that idea of 7 degrees of separation, where everything is related to everything. If you just go back far enough, kind of thing, you'll find a place on the planet where you can relate that point or that feature to anyway. And then I guess you start to question, well, how useful is this? Again, maybe it's just a great tagline.
Yeah, I mean, I definitely think it's a good opener to conversation for folks, and I think I like what you said, how much of data is actually spatialized, is spatially enabled, because it's a really low percentage. There's a lot of folks out there that are our customers, right? Who look at a spreadsheet of addresses and they think, well, that's location, right? That's an address. That's a location. You can put that on a map, right? And the answer is yes, of course, but we have to geocode it first. And they have no idea. They see an address and they think that's a location. I understand where that is. I look at that and I say it's in that city. I should be able to find that. Hey, look, I can even plug it into my phone and find it. And it takes some time and education, and that's part of our jobs as geospatial providers, is communicating and educating folks and say, look, when you type that into Google or into your iPhone, it's doing a process. It's actually doing GIS to translate that address into a lat long, into a coordinate that can be put on a map. Like you said, machine readable, because addresses are really, really hard for machines to read and to understand. They're really easy for humans to understand. A human can look at an address and say, well, it says 2164 Northwest Main Street. But I'm looking at this map that says Main Street. It's actually Main Street Northwest. That the modifiers at the tail end instead of the beginning. And a human can look at that and go, "Duh, yeah, okay, it's the same street. I'm in the right spot. I can find it. I just got to start looking for that house number." A computer looks at that and gets real confused real quick.
Yeah, and I think this gets back to that the fundamentals of GIS, geospatial, that we were talking about before. We still haven't solved these fundamental problems, and we can see this with the explosion of geocoders that are available around. This is a big business, turning human readable addresses into machine readable addresses and translating between the two. So I think, and that's again a fundamental thing in GIS, and the same when we were talking about that point in polygon and building relationships between things. These are fundamental problems that I can't see them going away anytime soon.
Right, I agree.
So I want to sort of round off this conversation by taking a look out into the future. And I guess I'd really like to hear your opinion on what you think the biggest opportunities in geospatial are at the moment.
Oh boy. Well, my crystal ball is just as cloudy as everybody else. I've never been a really great predictor of the future or a strategy person. I'm really more of an operational person. However, I do think there are lots of opportunities and in our future around automation where those things can take place. I think there's a lot more that can be automated in our industry, and supporting industries that are themselves automating. Now, self-driving cars are a big opportunity, of course. I think they're also a big danger and a huge, huge potential screw up of our society if we don't build our systems well enough for them. I would really like to see our cities and our planet be built more for pedestrians and bicyclists than for cars. I would like to see more investment being done there. However, I'm not blind and I can see the writing on the wall that self-driving cars get people really excited and they think about that. And there are obviously, by and large, the task of driving, especially down a highway that's very predictable, a freeway that has controlled exits and entrances, that task is probably better handled by a computer that can stay awake longer and can focus better and not get distracted as easily. And so those opportunities there are probably really great and probably hopefully going to be a boon to safety for our society. However, I once saw a quote from somebody who was working on automated cars and self-driving technology. The edge cases are endless with there. And when you get off of that controlled access freeway or highway, you're in an environment that humans are very good at navigating the ambiguity of with some basic training, and computers not so much. And so that I think there's a lot of opportunity for us in the spatial industry to make sure that we're paying enough attention to accuracy and precision in the information that we build, that we might be saving somebody's life if we do that. If we make sure that that address point is on the house, or offset from the road well enough that a computer can understand that that's a turn that needs to be taken. If we can make sure that our systems are built well enough to be able to support big and large amounts of data, then we can have a role in that industry of automation. And there's going to be a lot more other places that are not as sort of a third rail topic as self-driving cars, automating satellite imagery, that we're already seeing that happen in the industry. I think there's going to be lots more opportunities for folks to do that sort of thing, to be able to say, I'm getting a steady stream of information, whether it's from satellites or from drones or from gauges that are out there. And that information is really important for decision makers to have at a certain time or after a certain event or something like that. And we have a tremendous role in making sure that that is as fast and reliable and steady as possible. So when we're talking about things like earthquake response or wildfire response, those things, automating those tasks can be saving someone's life in the long run. And that's what we're here for. We're here to solve problems at that level, to solve problems large and small. And I think that's where the opportunities are. And so I do try to encourage folks that are in this industry to say, make sure you understand data really well and don't be afraid to code, because there's going to come a time when you are going to have a task that's going to make sense to automate. And if you can do that, then you have a lot of value to our industry and you have a lot of value to the world.
It was really interesting to hear you answer that question because it sounds like you have a lot of the same kind of thoughts that I have around it. I immediately focus on these big ideas like autonomous vehicles and AI and computer vision helping us plow through this mountain of satellite data that we're collecting every day and deriving information from that. For me, this is all sort of around the idea of automation, making things happen by themselves, giving the computer the smarts to solve problems for us and automatically communicate ideas out to other interested parties around the place. And you talked a little bit about coding there, about scripting, programming, and this is. So this is a big thing for a lot of people entering the industry, is that decision. Do I invest a lot of time and effort in learning how to code, or do I put my effort in another bucket? Can you give us a few more thoughts around that?
Yeah, I think it really depends on the person. It's I think everyone should try it. I think it's great that Esri has embraced Python as a an open source complement to their suite of products for accomplishing a lot of work. So I think Python is sort of the gateway drug of coding for geospatial folks. I think that's really cool and amazing that that opportunity is there. I think everyone should try it to see if it's for them. And I think they should try to solve a problem by writing code. So, one of the things that kept me away from both computer science and geography when I was younger was the abstraction. So, when I took geography classes in high school or college, there just wasn't a lot of attraction to me to memorizing capitals of various countries and various continents. Okay. It was very abstract, right? I've never been there. I've never seen it. It was hard to understand. And so, whereas when I got an aerial photo of my campus that I walked every day, suddenly it was concrete and it was real, and that abstraction was removed, and my mind was just blown. I could say, oh my gosh, I can apply geography at a local scale to places that I've been to, people that I've seen and visited. That is an amazing insight. The same thing has happened to me for code. When I first looked at code, and it took a couple of tries for me, I learned Avenue when it was big with ArcView 3. The reason I did well at learning that was because I had a problem that I could solve immediately. Okay, was able to take it beyond foo and bar. I can't stand it when I see examples out there, coding examples that use foo and bar. They're so abstract, they turn off so many people. Make it be an orange and a cat or something to that, anything that can be tied to the real world. I get it. It's a useful teaching, technique, and it works for some people. But for a lot of people, me especially, I really couldn't get into coding until I had problems that I needed to solve, until I had things that people needed me to fix and to automate. And so I think everyone should try it. I think if folks try it and give it an honest try to solve a problem, take it beyond that abstract and still decide it's not for them, I think that's okay. And understanding that about yourself is okay. And so now what's the next thing? What's the next sort of value you can give? Maybe it's a very deep understanding of a certain vertical, deeper than what I understand. If you are someone that understands real estate way better than I ever could, and you also know how to use GIS tools, you probably have a job doing that. So I think that's okay to do that, but I want everyone to try it first because it is for more people than are doing it now. I think there's a lot of gatekeeping in IT that needs to be broken down because we're shutting ourselves off from the numbers of people that can help us in this industry. And so I think more people should try it. And I think the more people that try it, the more options we'll have in our future in building a better IT, a better set of technological tools for a better society. So that's what I tell people. At least try it. Make sure before you decide it's not for you, make sure you've tried it beyond the abstract, beyond the foo and the bar, and touch it to something, a real world problem that you've been given or that you have yourself, and make that decision at that point.
I completely agree with a lot of what you said there, but I'd like to add that I think there's a real opportunity in this space, in this industry right now for communicators, people that really, really deeply understand these concepts, and perhaps that understanding will only come from having tried it yourself, and having gotten your hands dirty with a bit of Python code or whatever it is, but really deeply understand the problems that happen on the IT side and the solutions that the users are looking for, and can be that translator. So I think, yeah,
Absolutely.
in the pre-interview, you said something many things that were incredibly smart. But one of them was the job is not making the dots, but connecting the dots. Relationships between and among geography gives context to the world. I think that's that communication idea that needs to happen. We do so much in this industry. We talked a little bit before about how wide the gap is between people that are trying to do a point and polygon lookup and other people that are creating machine learning algorithms for real-time satellite data. We need people that can communicate what's happening, what's possible, how do we solve these things. Let's try and use the tools we have instead of reinventing the wheel the whole time.
Absolutely, and that's a great point that you made, and a great role for folks that have tried a lot of different things. Someone that understands a specific industry well and understands maybe not exactly how to write the code or how to design the database or how to run the spatial software. Maybe they don't understand every deep piece in there, but they know what's possible. They know what can be done. They know that a point and polygon lookup can be done. They know that satellite imagery can be downloaded daily if you really want it. So there's definitely a role for folks that can understand those things well enough and connect the dots. So, like I guess I said a couple of weeks ago, connect the dots for folks, help them understand that, okay, yes, you have a problem. It may be a very special problem and a very unique problem, but it might not be. It might be a problem that we've seen in other areas and that we can solve. We have technology that can solve it. We have solutions that can be built in very little time to solve that problem. And the communicator's job is just helping people understand that from fundamental levels, helping communicate those problems between the IT and the customer, and helping, sometimes the communicator's job is to sell the idea, right? To go in front of the decision makers who hold the purse strings and say, this is what we should do. This is how we should solve that problem. We have the technology. We understand the problem. We can build it. And then they've got to go and get the money to do that and execute.
Mike, I've really enjoyed this conversation. It's been so interesting hearing your views on the different topics that we've covered today. But it is time to say goodbye. But before I let you go, can you just let the listeners know where they can go to follow along and learn more about you?
Yeah, I think probably the best place to follow me is on Twitter. My handle is Dolbow, Dolbow. So that's my handle. But also, I generally run the GeoHipster Twitter account. So if you have questions, you want to get in touch with me, you can direct message me at either of those accounts, and I'll usually see it within a day or two. And really, I encourage people to use Twitter, especially in the geospatial industry, because it's a great way to break out of our bubble, whatever that bubble is. Maybe we're in an Esri bubble, but maybe we're in an industry bubble or something like that. We're in a bubble that is for a specific vertical. And being connected to geospatial professionals on Twitter, to me, has been a boon for my career. I would have never found out about GeoHipster from Adonis without Twitter. I would have never met so many of the really cool people that I've met and learned about a lot of the things I've talked about today without that. And let's be honest, when people do political discussions or whatever on Twitter, it becomes kind of a cesspool. But geospatial Twitter is really friendly, really supportive, really a great group of people that are in the circles that I've been able to follow. And it's, to me, that's a great reason to be there. And it's much better customized news feed in our industry than going to Google News. If you take GIS into Google News, I think the first thing that comes back is the General Mills stock ticker. So, you know, if you go, whereas if you follow some geospatial professionals on Twitter, you're going to learn things and find out about things that you would never have seen pop up in the news. And I think that's a really cool way to connect. So that's how I would encourage people to connect with me. And I'm ready. I do use Twitter in kind of a weird way. I only follow 100 people or accounts at a time. So unfortunately, I don't do a lot of follow backs. That's not my style on Twitter. So I'm a little weird there. But if you direct message me, I will get back to you. Or if you comment on one of my tweets, I will at least favorite it or respond back. I try to do that because I think that's what people have given me over the years, to be able to take me under their wing and coach me on something or provide opportunities for me. And I love to give that back to other folks. If they ask a question, how did you get that done? I'd love to be able to answer that question for folks.
Well, I really hope people take you up on that and contact you on Twitter. Thanks again, Mike. I really appreciate it.
Yeah, my pleasure. Thanks for having me. And, if you don't mind, I'd like to do a quick plug. I don't know when this podcast will be out, but GeoHipster did just release our 2020 calendar yesterday. We released it for Post GIS Day in honor of that hashtag. And it's a great product. It's got some great maps in there. If people could go out and check that out, you could have something really cool to hang on your wall for all of next year.
I will definitely link that up in the show notes for people. Thanks again, Mike.
Yeah, my pleasure. Thanks for having me.
Thanks again to our generous sponsors, HiveMapper. Not only do they help make this podcast possible, but they have created this amazing platform which lets you upload video data and have it automatically converted into 3D geospatial layers. So that all sounds very simple, but you might be wondering, well, where do I get that data from? Well, in a very simple example, you could take a GoPro camera, strap it to a drone somehow, fly it over an area, and you've collected the data that you need to create these 3D geospatial layers in HiveMapper. It can be that easy. And that's the thing that I think is really amazing about this platform. You can use a variety of different sensors. You don't need to do any pre-processing of data. Just upload the video footage as it is. You need no positioning metadata attached to that. Just upload it and it'll do the rest for you. And that's it for another episode of the Mapscaping podcast. My name is Daniel, and I just really want to thank you for tuning in again this week. It's much appreciated. I also really want to give a big shout out to all the people that have taken the time to rate and review this podcast on iTunes, on Apple Podcasts. It really helps us out. It also gives me an idea of the things that I can improve and perhaps what direction I should take it in the future. As always, there are some useful links in the show notes, and you are more than welcome to reach out to me for whatever reason on social media. Thanks again. We'll see you next week. Bye.